For this lesson, we're going to be talking about odds. So odds are used when you want to compare the likelihood of an event occurring compared with the likelihood of it not occurring. So I want to look at a particular event and I want to just compare how likely is it to happen and how likely is it to not happen. So we actually talk about odds quite a lot in our daily life. Oh, odds of that happening are, you may hear it with a lottery. Oh, your odds are 1 in 4. If you're just hearing about a contest, something like that. We actually talk about odds very frequently. So here's our first formula. We'll jump right in. And our first formula of our odds in favor of event A occurring are my probability of event A occurring divided by my probability of A not occurring, or A complement. Now we can also write this out as a, try to think of the word. Why can't I place that word? We can write it out with the colons here. I can't place the word, what we call that. Ratio. Thank you. There it is. Was not coming to my brain, so thank you. So we can also write it as a ratio, and that's typically how we actually talk about these is 2 to 4, 3 to 6, something along those lines. We usually use ratios for this. So let's do a few examples. These are easiest to do with examples to understand how to work with them. So example 1, we want to determine the odds in favor of rolling a 5 with 1 die. So what we do is we want to first find our probability of this happening. So our probability of rolling a 5, there's 1 5 out of 6 total options when rolling a die. Then we also need the probability of this not happening. So there are 5 other options, so 5 out of 6. We can also use the complement, so 1 minus 1/6, doesn't matter, however it makes more sense to you. So to find our odds, we take our probability of A divided by our probability of A complement. So that will give us 1/6 divided by 5/6. When we divide fractions, we flip the second one and multiply. So you'll notice that these 6's cancel, and we have 1 over 5, or 1 to 5 as our odds. So once we find those two probabilities, the calculation isn't too bad, just a little bit of dividing fractions, but the more we practice with it, the better we will get at it, and it will come back to the front of our brains. So for B, we want to find the odds in favor of drawing a spade from a standard 52 card deck. So let's find our probabilities. So our probability of drawing a spade, there are 13 spades out of 52 cards. We could reduce this to, it's up to you. I'm just going to leave it like this just to make it a little simpler. Then our probability of a complement, or not drawing a spade, 1 minus 13 over 52 will give us 39 out of 52. I'm just going to keep it like this and not reduce that first one, just so that things cancel and it makes the math a little bit easier. So now we find our odds. Probability of A divided by our probability of A complement. So that will be 13 over 52 divided by 39 over 52. So we flip the second one and multiply. Oops. Forgot to flip the second one. There we go. We have some 52s canceling out here. So that will give us 13 over 39. Or we can reduce this to we can reduce that to 1 over 3 or 1 to 3. Either of those is totally okay. So if you want to express it as a fraction or a ratio, it doesn't matter. Whatever you're more comfortable with, both of those are totally fine. Okay. So let's try another one that is a little bit more challenging. If I'm going too fast, you need me to go over something again, just let me know. Okay. So Brad and Derek are trying out for the basketball team. There are 20 boys in total at tryouts, and the coach is only going to keep 10 players. What are the odds that both Brad and Derek will make the team? Okay. So we want to determine the probability that both Brad and Derek make the team. So we'll let event A be that they both make the team. Brad and Derek make the team. So let's find the probability of this happening. So our probability of event A is equal to the number of ways A can happen. So the number of ways they could both be on this team divided by my total number of ways that the team could be chosen. So for our total number of ways the team could be chosen, the coach has 20 athletes in total and is going to choose 10 of them. Then for the number of ways that we could make a team with Brad and Derek both there. So Brad and Derek have to be on the team. So that means we only have 18 people to choose from because Brad and Derek have already been selected. And we're going to choose 8 of them because we only have 8 more spots because Brad and Derek took up 2. So now this will be equal to 18 choose 8, 43,758 divided by 20 choose 10, which is 184,756. So you can already see how unit 1 is coming about in unit 2. And then we can reduce this. You can kind of work with reducing it slowly just for the purposes of time. I'm going to quickly write out 9 over 38. That's what it reduces to. If you keep like trying different things and slowly reducing it, you'll get to 9 over 38. But just for the purposes of time, we'll jump right there. So when we're finding odds in favor, we need to find the probability of the event happening, as well as the probability of the event not happening. So to find the complement, 1 minus the probability of the event happening, which will give us 29 over 38. There we go. And if that was a little bit confusing using the combinations within the probabilities, don't stress. That's what our whole next lesson is about. So if that was just a little bit confusing, that piece, we're going to be doing a ton more about that. So you'll get tons more practice with that stuff. Okay, so now we'll find our odds. So to find odds in favor, probability of the event happening divided by the probability of the event not happening. So our probability of the event happening, 9/38, divided by the probability of the event not happening will be 29/38. Then for fractions, we flip the second one and multiply. Again, you're noticing that those denominators cancel. So we get 9/29, or we can express it as a ratio. There we go. Either of those would be absolutely fine answers. Okay. Any questions there about that stuff? Okay. So now for here, if you notice, we've been canceling out similar numbers over and over again. You notice we've been canceling out those denominators over and over again. And that isn't by mistake. It happens all the time. So these denominators will always cancel. So that means that the odds in favor of A, if we have this information, we can actually also use this formula here. Now, we don't always have enough information to do this. So that's why sometimes we need to use the probabilities. But sometimes if we just have the number of ways each could happen, we're good to go. So we could also do the number of ways the event can happen to the number of ways the event will not happen. So I'll show you how that works and why that works right now with a little bit of a proof. So here's our original formula. Probability of A divided by the probability of A complement, like that. Now, if I filled this in with my formulas, number of ways A can happen, divide by the total number of outcomes, divide by, number of ways A complement can happen, divide by my total number of outcomes. Then we flip the second one and multiply. And then you can see this cancels right away like this. And we get the number of ways A can happen divided by the number of ways A complement can happen, which we could also write as a ratio. So either way works. In some instances, it's a little bit easier for us to use one than the other, especially if we're just given probabilities and we don't know the number of ways it could happen. But if we do know the number of ways, it's way easier and quicker to calculate that instead of going through and calculating all of these probabilities. Okay. Any questions about that before we move on to odds against? We're good? Okay, let's try odds against. A very similar idea, but we just switch things around. So for odds against, we would have the number of ways the event does not happen to the number of ways the event does. So exactly the same, we've just swapped them. So this is why it's so important to read your question. If it's looking for odds against, it means we have to swap them. So be very, very careful with that. So let's look at the odds against rolling a 5 with one die. So our number of ways it could not happen, and then the number of ways it could happen. So, oops, that should have a colon there. So on a standard die, there is 1 5. So that's how many ways it could happen. And there are 5 other numbers. That would be the number of ways that the event does not occur. There we go. So basically the same as the other one, just swapped. Similarly here, drawing a spade from a standard 52 card deck. So our number of ways we could not pick a spade and the number of ways we could pick a spade. So there are 39 cards that are not spades and 13 cards that are spades. And there we go. So simple as that, basically just swapped. That's all. So just be super careful when you're reading your questions that we're looking for the words odds against, things like that. We just want to be very, very careful. All right. So for 4, the chances of drawing a blue M&M from a new bag of M&Ms is estimated at 0.2. So our blue M&Ms probability is 0.2. What are the odds against drawing a blue M&M on the first try? So what we'll do is we will let A be the event of drawing a blue M&M. And now, because we're not given the number of ways it could happen, we don't know how many M&Ms there are, what we'll do is we'll look at the probabilities in this case. So my probability of drawing a blue M&M is 0.2. My probability of not drawing a blue M&M, or the complement, is 1 minus 0.2, which is 0.8. So for my odds against, same formula as before, I just swap it. So now we take our probability of the event not happening, and we divide this by the probability of the event happening. So we'll have 0.8 divided by 0.2, like that. And we can also write it like this. It's up to you. There we go. And we don't want to have any decimals when we're looking at odds. We want to just have whole numbers. So I'm just going to multiply. Oh no, my Notability crashed. Sorry. Oh, we'll have to back up a bit. That's okay. So our probability of drawing a blue M&M is 0.2. Then the complement, the probability of not drawing a blue M&M, is 1 minus 0.2, so 0.8. So now, because we have probabilities, we'll use the probabilities to find our odds against. So we'll have our probability of a complement divided by our probability of A. Our probability of a complement is 0.8. 0.2. So we don't want to have any decimals, so I'm just going to multiply both of those by 10 to have 8 over 2, which reduces to 4 over 1, or 4 to 1. Again, you could use a fraction or a ratio. It doesn't matter, whatever you're more comfortable with. Okay, any questions before we do one more example that gets a little bit trickier? Just one last little piece. Yes, this was a really good question. So it can't stay 0.8, 0.2. No, it can't. We need whole numbers. Here, we need whole numbers. And that happens sometimes with our probabilities, so just be mindful of that. Okay. So last one, finding probability given odds. So going the other way. So if our odds in favor of A are PQ, so PQ, then the probability of event A is P all over P plus Q. Just before I get to this, there was just a quick question about the previous example. When looking at odds, would you read it like 4 times more likely to not draw the blue M&M or something like that? So how we would say this is the odds are 4 to 1. There would be basically 4 ways to draw one that's not a blue M&M and 1 way to draw one that is blue. So the odds are 4 to 1. That's what I would say. Hopefully that makes a little bit more sense. So if you break it down to its smallest, most reduced form, it would be like I have 4 other colors and 1 blue. That's how that would kind of read if you needed to explain it. Okay, so if we're given odds and we want to find our probability, if the odds in favor are P over Q, then the probability of A is P over P plus Q. So again, this is for odds in favor. Just remember if it's odds against, then that fraction is flipped. So just be really mindful of your wording. So the odds of drawing a yellow or orange M&M on the first try is 1 to 3. What's the probability of drawing a yellow or orange M&M on the first try? So the odds of drawing a yellow or orange M&M is 1 to 3. So odds in favor are 1 to 3. So that means that this is P and this is Q. That's what that means. So now to find our probability of drawing a yellow or orange M&M, we have P over P plus Q. Once we've identified them in the odds, filling them into the equation isn't too bad. So P is 1 and Q is 3. So the probability is 1/4. So we're just going backwards, but this is how you approach it. Are there any questions about this stuff? If there are, feel free to type them in the chat. I'll write out the homework questions.